Hi algebra students, this lesson is going to be on writing linear equations. This lesson we are going to do in two parts. So this first lesson is going to be on writing linear equations given different information. So there's certain information I could give you and ask you, can you write an equation using this information? We'll do some of these combinations of information in this first part, and then there'll be a second part you watch tomorrow with even more examples. So with all of that said, we can go ahead and begin. The first thing we're going to look at is similar to what you had your last lesson on, which was last Thursday. Last Thursday, I was giving you an equation and then asking you to graph a line for me. We are going to start today off by doing the opposite. So instead of me giving you the equation and you giving me the graph, I am now going to give you the graph and you are going to give me the equation. Now, when we were graphing last week, I know it's been like 5 days now since we last did that lesson, so I know it's been a while, but do you remember the formula we were using to help us graph everything? Well, the formula we were using was slope-intercept form, which looks like y equals mx plus b. If you didn't remember that, that's okay, but hopefully it looks familiar now. If it doesn't look familiar, make sure you watch the graphing video. You want to watch that before you watch today's lesson. In this formula, we had talked about how x and y are always going to be in the equations, and m here represented the slope of the line. Remember, slope is a number, and that number tells you the direction of the line. And then b here represented the y-intercept. The y-intercept was that point where your line crossed the y-axis. So if we were using this equation to graph, the first thing we were doing was we were starting at our y-intercept, plotting a point, and then using slope to make more points. What we're doing today is similar, except I'm looking at this line and I need to figure out the slope and the y-intercept in order to write the equation. Looking at this, it does not matter where you start. Usually I like to start with my y-intercept just because when we were graphing, that's usually where we started. Looking at this graph, can you tell where the y-intercept is? Remember, the y-intercept is the point where your line crosses your y-axis. For this line, that point is right there. Now this graph doesn't have any numbers on it, so we have to count. The origin here at the middle is 0. So this is -1 and -2. That means that y-intercept is the number -2. Now what about the slope? When we were graphing lines, there's something we used for slope to help us graph more points. Do you remember what that was? Well, slope, you can say, can be represented with the formula rise over run. This is the third lesson in this unit. Our first lesson, we practiced finding slope of lines, of graphed lines like this. Remember, we would count our rise, count our run, get a fraction, and then see if we could divide or simplify. When you're counting your rise over run, in general, it helps to start on the left side and go to the right side. So there are 2 points they've already marked for me, here and here. I'm going to start with the point on the left side of the graph and count my way to the right point. Now when I count, I'm not trying to count diagonally. I want to count my rise, so up and down first, and then my run, which is sideways. Starting at this point, I need to count how many I have to go up or down to get this point. I'm going to have to go down. I'm going to need to go down 1, 2, 3, 4, 5, which means my rise is, well, I was going down, so -5. And then my run is how much I have to go over. Here, I'm starting from where I had already gone down, and I'm going to count 1, 2, which means my run is 2. Now we got the fraction -5 halves. I'm going to ask myself, can I divide that? Nope. Can I simplify that? Is there a number I can divide 5 and 2 by? Nope. So that right there is our final answer. Our slope is -5 halves. Now if you remember, I said with these graphs, one of the biggest mistakes students make is with the sign. Remember, we learned if a line is going up on your graph from left to right, it's going up. That means positive slope. If your line is going down from left to right, that means negative slope. So a good thing to do is just check that line real quickly, look at it. I notice the line is going down, which means I've got the sign right. My sign should be negative. Once you have these two pieces of information, you can use all of that to write yourself an equation. Remember, we've already got slope-intercept form. We've got this formula here. All you have to do is replace your numbers. Remember, x and y are always going to be in the equation. So it's going to begin y equals. But instead of writing mx, I need my slope, which we said is -5/2. Sometimes students forget the x. Don't forget your x. -5/2 x. And then my y-intercept, my b, we said is -2. Now I know the formula says plus b. You can write plus -2, but the simplest way to write it is just -2. And we get this for our equation. Ta-da! We've got one more we'll look at together. This one here, we've got the same idea where these are the two things we need to find to help us write an equation. Now eventually, I'm not going to be giving you this. You're going to have to know on your own, this is the formula I want to use when I'm graphing, so these are the two things I'm going to have to find. But for now, I've got them here for you to kind of prompt you in what you're going to need to do. Looking at this equation, go ahead, what do you think the y-intercept is of that line? Well, here's my y-axis. It crosses at +2, so my y-intercept is 2. Now the difference between this line and the line over there is that line marked points for us. This line has not marked any points. We need to find another point so that we can count our rise and run for slope. Looking at this line, remember you want to pick points that are on those graph lines. So if this is the graph, I want to pick a point that lands here or here or here or here, not ones that are in the middle or in the middle of the line. It has to be exactly at this intersection. So if I follow my line, there's a point here we could use, there's a point here we could use, there's a point here we could use. Any of those are good. You just need 2 points. And it does not matter which 2 you choose. I'm going to go ahead, I'm going to use these 2 in the middle. When I count, or how about you do it first? What do you get for your slope for this line? Okay, how'd you do? Our rise is 1, 2, 3. Notice I'm starting on my left point and counting to the right. So the rise is 3, up 3, so +3. Our run is 1, so we get 3/1, which just equals 3. If you can simplify or divide, make sure you do that. So if you said 3/1, you're not wrong, but that's also not how you're going to see the answer. You're going to see a 3. So we've got our slope is 3. Our y-intercept is 2. I'm going to do a quick direction check. My line is going up. Lines going up mean positive slope. My slope is positive, so my signs are good. What about that equation? What's that equation going to look like? Well, I'm using slope-intercept form again. So I've got y equals mx. Well, m is my slope. My slope is 3, so I can say 3x, and then plus my y-intercept, so +2. And we get that for our equation. Similar to what we did in graphing, just going the opposite direction. I'll go ahead and erase these examples, and then there'll be 2 for you to try. This first one here, go ahead and represent an equation of that line. All right. If I was doing it, I see that 2 is my y-intercept. I need another point. It does not matter. There's a lot of points on this. Doesn't matter which one you choose. If you choose points closer together, it's going to mean you don't have to simplify. If I pick points really far apart, that's going to give you 4/8. There's a lot of simplifying to be done there. If I pick points closer together, though, for my rise over run, it's going to be up 1/2, which is already simplified. It's a half, which would give me my equation, y equals 1/2x plus 2. What about this other line here? Go ahead and write an equation. All right. Well, our y-intercept, it crosses my y-axis at the origin. What number is that? 0. Our slope, they've got these 2 points already marked for you, so you could use those if you want. It's going to be down 1, 2, 3, 4, 5, 6. down 6 over 1, 2, 3. Negative 6 divided by 3 equals negative 2. If you're using the slope-intercept form, y equals mx. That would be negative 2x plus b, so plus 0. If you write that, that's not wrong. Again, you've got it right, but it's not how you're going to see your answer. Do you know what we need to change here? Well, we had seen when you're graphing, if that y-intercept is 0, you don't see a plus 0, you just see nothing. The same thing is true about when you're writing equations. If that y-intercept is 0, you're not going to write plus 0. You're just going to say y equals negative 2x. These are our first examples of how to write equations. So at this point, we have talked about how you write an equation if you've got a graph. Now remember when we first started talking about graphing linear equations, I started off with a graph of, it was like Robin's 3 children and their bank accounts, and then we looked at a graph with the graphing linear equations about temperature. I've got another real world example to show you what this would look like. So here we've got, it tells us the graph to the left shows Joanna's savings account. So I can look at the graph, and one of the first things you want to check are what the x and the y-axis say. So I can see my x-axis down here says months. So it's counting by months down here. We got 1 through 12. And then this side here says the number of dollars in savings account. So they had told us it's showing Joanna's savings account. This shows how much money or dollars is in her savings account. But notice the numbers here are not going up by 1. They're going up by 100 over here. There's 3 questions to go with this. The first question asks, how much money did Joanna start with in her savings account? Well, what do you think? Well, the starting point is going to be month 0. It's also going to be where our line starts. Our line starts right here at month 0 at $300. The amount of money she started with is $300. Now, if I wanted to use a vocabulary word we've learned with linear equations to describe that, what could I use? Well, 300, that starting point, is your y-intercept. When we graph lines, we're always starting at our y-axis. This would be that starting point. It would be the y-intercept. The second question asks, how much money does Joanna deposit each month? Go ahead and try that. Well, we can see month 1, she's got $400. Month 2, $500. Month 3, $600. What's happening? Each month she deposits $100. How much money does she deposit each month? $100. Now again, there's a new vocabulary word for linear equations you can use to describe this. Do you know what it is? Well, what we were looking at a moment ago is how much it's rising every 1 month. We're looking at the rise over run. We're looking at the slope. $100 is the slope of the line. It's telling me this line is going up. Positive number means it's going up. It is going up $100 every month. That line is increasing $100 every month, each time. Now this last part, write an equation to represent Joanna's savings. Use all of this information we already said. We said she's starting with $300. She's saving $100 each month. I've given you something like that in a word problem before. All I've done now is we got all that information from a graph, but you know how to write an equation for that. What would the equation look like? Well, if I wanted to write an equation for her savings, my equation could start off, I'm going to put it here because I'm afraid this is too low. My equation could start off S equals, S for savings. Her savings equals, well, it started with $300, and she's adding 100 each month. 100 each month. Right there, that's our equation. But look, if I try comparing this to all the stuff we've been doing with linear equations, we've got that number without the variable. Our y-intercept is at 300. And we've got our slope, that number with the variable, 100m, is how much it's increasing each month. All these things are connected together. And one of the things we're doing right now is we're giving you little examples as we move on. But sometime this week, we're going to do a lesson that's just all application problems like these. So you can really start to see how these word problems and real life stuff are connected to linear equations and all the work we're doing right now. I've talked enough about this problem. We can go ahead and jump into the next part, which is another way you can be asked to write linear equations. So for example, instead of me giving you a graph, I could give you this information here. So write an equation of a line that has the slope of 2 and a y-intercept of 6. Notice we're given the slope. We're given the slope is 2. The y-intercept is 6. It's the same information we were getting from the graph earlier, just now instead of me giving you a graph, you having to do the work to find that, I'm giving it to you in words. But the idea is the same. If I want to write an equation, if I know slope and y-intercept, we're going to use our handy-dandy formula, the slope-intercept form, which is y equals mx plus b, and substitute those numbers into this formula to write our equation. An extra step that you might want to do to be helpful is label your information. Slope is 2, so I can label my 2 with an m, since we use m for slope for whatever reason. And then your y-intercept, it says a 6, so we could label that with a b, since b is what we use for y-intercept. Doing that just helps you make sure you get the numbers in the right spot. So our equation would be y equals, my slope is 2, and my y-intercept is 6. So y equals 2x plus 6. I think these are probably the easiest ones because they're giving you all the information you need. All you have to do is just substitute, and you're done. Go ahead, try this second one for me. All right, be careful because I switched around the information. The slope is -4 and the y-intercept is 3. So you would want -4x minus 3 for your answer. There is one last type of example we're going to look at. In this last example, I'm going to jump ahead for a moment. Tells us the equation of a line that has a slope of 2 and goes through the point -3, 1. So this time they're giving us different information. They're giving me the slope, same as before, but instead of giving me the y-intercept, instead of giving me the point where our line crosses our y-axis, they're giving me a random point. They're telling me it goes through the point -3, 1 right here. Because the information is not the same as before, I can't use that same formula. If I tried using y equals mx plus b, yes, I do know the slope. I do know the slope is 2, but I don't know the y-intercept. This is not the y-intercept. That point is like over there. It's not on our y-axis. This is different information, so I can't use this. The good news is there's something else we can use. One formula we use when we're talking about linear equations is slope-intercept form. That's what I just had written. The other formula you can use is a formula called point-slope form. It's called point-slope form because it looks like y minus y1 equals m times x minus x1. And m is your slope. And that x1, y1 right there, x1, y1 is a point. Hence, point-slope form. We're going to say it's a point, specifically a point on the line. So for these, you've got two formulas. You've got this one, and you've got slope-intercept form. These names are not creative. Match the name of the formula to the information you're given. If you're given slope and y-intercept, you use slope-intercept form. If you're given a point and a slope, you use point-slope form. Just match what you know about the line to which formula is going to help you get there. So since we know our formula now, I'm going to go back to that question we started looking at. I am not going to erase that formula. So looking at what they told me again, they told me that the slope of the line is 2. We could do the same thing we did before, label it. Slope is m. So that tells me 2 is my m. 2 is going to be going right here. And then we've got, it goes through the point -3, 1. You're going to label this point as x1 and y1, just like we did in the first lesson of this unit where we were finding slope from points, x1, y1. Looking at that, now that I've got all the information labeled, all I have to do is substitute it into my formula. So here's my formula. Just like slope-intercept form, it's always going to have x and y. I'm not changing those. What I am changing is the m, the x1, and the y1. So what it's going to look like is it's still going to say y minus, but instead of y1, I'm going to substitute 1 equals m, our slope, which is 2, times x minus x1. Well, x1 is negative 3. Now be careful. We want minus x1, so I want minus negative 3. I want minus negative 3. You need 2 negative signs there. You can leave it like that if you want, or what I prefer to do, I know 2 negative signs are going to change to a plus sign, so I just go ahead and do that right away. So we've got y minus 1 equals 2 times x. This is a plus sign now, a messy plus sign. Oh my gosh. There you go. We have 2 times x plus 3. Now this is an equation. That's what it wanted. It wanted an equation. I've written an equation of this line. The problem is, kind of like what we saw when we were graphing linear equations, lots of times, yeah, this is an equation, but it's not a helpful looking equation. The most common way to write your linear equations is in slope-intercept form. And this is not in slope-intercept form. We would prefer our answer to look like this. So looking at what we've got right now, there's some things we can do to change it so that it does look like this. What's one thing you think we could do? Well, usually in class I see parentheses. The slope-intercept form doesn't have parentheses, so let's get rid of those. And I would say, yes, that sounds like a great idea. Let's do that. Let's multiply that 2 to what's inside the parentheses. That would give us y minus 1 equals 2 times x is 2x. 2 times 3 is 6. So we're left with that. Now there's one other thing we need to do. Well, our formula says y equals. I don't have y by itself yet. I need to get rid of that minus 1 with a plus 1. I'm going to add 1 over here to my 6 as well, because whatever you do on one side, you do on the other. And that's going to leave me with y equals 2x plus 7. And this right here is your final answer. It is in slope-intercept form. We've got our slope is 2, which they had already told us. But now that we've changed it into slope-intercept form, I can see that our y-intercept is 7. Now, I did have a graph over here. My graph is a little too tiny, so I'm very sorry. It's 1, 2, 3, 4, 5, 6, 7. What I was going to say is let's go ahead and graph this line over here to check to make sure our answer matches up with this information. So it is a little tiny because my first thing I need to do is mark my y-intercept, which I'm going to say is right here. Let's just pretend this line keeps going up. So I've got 1, 2, 3, 4, 5, 6, 7. Our slope is 2. If my slope is 2, that means my rise over run is 2 over 1. Now I'm already off the graph. I don't want to go up anymore. I don't want to go up 2 over 1. But what we can do is the opposite. Instead of going up 2 over 1, I can go down 2 backwards 1, which puts me right here. And I can keep going. I can go down 2 backwards 1, down 2 backwards 1, down 2 backwards 1, until I have no more graph. Go ahead and draw my line through this. Now if this is the correct equation, I just graphed to this line here. If it's the correct equation, what should be true? Well, it should have a slope of 2, and it should go through the point -3, 1. Let's check to see if both those things are true. Well, the first part, does it have a slope of 2? Yeah, the line's going up, so the positive slope, and it's going up 2 over 1. So it has the slope. What about the point? Does it go through the point -3, 1? Well, -3, 1 is -3 on your x-axis, +1 on your y-axis. That is right here. It does. It goes through that point. So we've got both things. This is the equation of the line that has a slope of 2 and also goes through that point there. This was the last example I have. There is one for you to try, which you will be able to see much better once I erase all of this. Okay. We've got, you are going to write me an equation of a line that has a slope of 1/2 and goes through the point 8, -2. Go ahead and try that. All right. I did give you the one that was a little more fun because you got to do the one with the fraction. If you are using the formula y minus y1 equals m times x minus x1, when you substitute y minus y1 is y minus -2, which we can just say y plus 2. Your slope is 1/2 x minus x1, which is 8. So we get that line there. Now, just like last time, we want to change it into slope-intercept form. So the first thing you would want to do is distribute your slope, distribute 1/2. 1/2 times x is just 1/2 x. 1/2 times 8. In class, people are like, oh, I don't know how to do that. Yes, you do. Multiplying a half is the same thing as just taking half of the number. 1/2 times 8 is the same thing as 1/2 of 8, which is 4. If you didn't know that trick and you wanted to do it by hand, what I recommend is if you're multiplying fractions, it actually helps to have them both look like fractions. So I'm going to change 8 to be 8/1. We aren't cross-multiplying. This isn't an equation. It's a multiplication sign. You are just multiplying straight across. 1 times 8 is 8. 2 times 1 is 2. And 8 divided by 2, hey, look, 4. If you've got that part, I think you're probably good on the rest. The last step is to get y by itself by subtracting 2 on both sides. That's going to leave you with y equals 1/2 x, and then -4 minus 2 gives you -6. Hopefully you're feeling pretty good about these. Make sure you do the homework on this assignment to get some practice, because what we're doing tomorrow, remember, is part 2 of this lesson. And we're going to be using all of these fun skills to help us learn some more problems. Thanks so much for watching. Bye.